The OWASP Top 10 for LLM and AI applications identifies critical security risks when integrating large language models into applications. This guide focuses on application-level risks, complementing the Machine Learning Top 10, which covers ML lifecycle hygiene, both crucial for comprehensive security. First, prompt injection, or LLM-01, occurs when an attacker crafts input to manipulate system prompts, leading to secret disclosure or unauthorized actions. A classic example involves embedding a hidden command within an uploaded document, causing the LLM to reveal API keys or generate malicious code. Attack surfaces include public input fields, file uploads, multi-turn chat contexts, and retrieval augmented generation chains. Mitigations involve strict input normalization, separating user text from system instructions, and applying prompt scanning filters. Next, insecure output handling, LLM-02, arises when LLM outputs like HTML or shell scripts are consumed downstream without proper validation, risking XSS or command injection. For instance, an LLM might generate an HTML snippet with unescaped script tags, or an agent could execute a model-generated shell command without validation. Mitigations include treating model outputs as untrusted, escaping encoding before rendering, and requiring human approval or strict schema validation for generated code. Third, training data poisoning, LLM-03, involves attackers injecting poison data into datasets, causing models to learn malicious behaviors like backdoors. A model might misclassify inputs only when specific trigger tokens appear, or a generative model could output proprietary training text. Mitigations include data provenance tracking, vetting incoming data, anomaly detection, and using differential privacy. Fourth, model denial of service, LLM-04, involves resource exhaustion or adversarial inputs that degrade performance or force high-cost computations. This can manifest as spikes in CPU/GPU time from complex prompts or repeated heavy retrievals hitting vector databases. Mitigations include rate limits, per user quotas, prompt complexity caps, and pre-screening inputs for resource-heavy constructs. Fifth, supply chain vulnerabilities, LLM-05, involve compromised third-party models, packages, or dependencies, such as pre-trained weights with backdoors. A model's behavior might change after swapping an upstream package, or a new dependency could introduce network access. Mitigations include model provenance with signed artifacts, dependency scanning for code and model weights, and reproducing training in controlled environments. Sixth, sensitive information disclosure, LLM-06, occurs when models unintentionally output PI, secrets, or private data from training or prompt chaining. This could be a model repeating API keys or internal documents verbatim, posing a significant security risk. Mitigations include not including secrets in prompts, masking/tokenizing sensitive fields, redacting outputs, and using extraction-resistant training. Seventh, insecure plugin/extension design, LLM-07, involves plugins or connectors with weak authentication, excessive permissions, or insecure endpoints. A plugin might expose sensitive data or allow the model to trigger actions without sufficient checks, leading to unauthorized operations. Mitigations include the principle of least privilege, fine-grained scopes, strong authentication like OAuth, and security reviews of third-party connectors. Eighth, excessive agency/autonomous actions, LLM-08, occurs when LLMs take actions without human oversight, leading to harmful or irreversible outcomes. An LLM agent might execute multi-step workflows causing data loss or performing fraudulent actions because it decided to. Mitigations include human-in-the-loop gating for sensitive actions, capability bounding, sandboxing, and requiring multi-factor approvals for high-impact operations. Ninth, over-reliance and misuse, LLM-09, describes blind trust in model output for safety-critical decisions without verification. Teams might adopt model suggestions as fact, leading to business or safety errors in critical domains like legal or medical fields. Mitigations include encouraging uncertainty reporting, human review for critical domains, and requiring citations or evidence for factual outputs. 10th, model theft/extraction, LLM-10, involves attackers repeatedly probing an API to reconstruct the model or exfiltrate proprietary datasets. This could involve black box extraction attacks that approximate model responses, allowing competitors or attackers to reproduce the model. Mitigations include rate limits, per-user quotas, anomaly detection on query patterns, output perturbation, and watermarking outputs. Practical controls and tools include strict input and output filters, RAG hardening, and rate limiting via API gateways. Telemetry and CM systems are crucial for logging prompts, retrievals, and actions, alerting on anomalies. Adversarial testing, like prompt fuzzing and red teaming, helps identify vulnerabilities in the application. Supply chain safety involves signing model artifacts, tracking dataset provenance, and scanning third-party code. Privacy measures like differential privacy during training and redacting sensitive data and persistence are also vital. A quick engineering checklist emphasizes never injecting raw user input into system prompts and sanitizing all LLM outputs. It also includes rate limiting and monitoring every API and plugin, along with signing and verifying model and dataset artifacts. Requiring human-in-the-loop for sensitive actions, maintaining immutable audit logs, and running scheduled adversarial prompt tests are crucial. Applying differential privacy, minimizing sensitive data in training, and using provenance and watermarking deter theft. Finally, training staff and running tabletop LLM incident drills quarterly ensures preparedness. For